This is section 8.6, part 1, solving rational equations. Okay, our objectives for this whole entire section is we're going to solve rational equations now, and we're going to use rational equations to solve problems. Okay, now we're going to specifically talk here in part 1 about solving monomial rational equations. So in your denominator, you're going to have a one-term item. Okay, so these are kind of the rules or kind of the steps to go through and solve rational equations. They are different than rational expressions, again, because now we're going to throw in an equal sign into our problem. Okay, so first step, we're going to look at our fractions and we're still going to identify a common denominator. That's the very first thing we got to do. That's going to be very important. Okay. We also have to do what we call identifying your extraneous solutions of the problem. This is very similar to a domain. Okay? And what you're going to see is you're probably not going to see it today in the problems that we look at, but you will start seeing them when we do polynomial ones. Okay? Now, once you find your common denominator, you're going to take your common denominator and multiply the whole equation by the common denominator to eliminate all fractions in the problem. Now, the reason I do it this way is, again, many of you are not very sound when it comes to dealing with fractions. So if we don't have to have them, let's get rid of them. Okay? So I'm going to take and multiply the common denominator by everything. Then I'm going to distribute the common denominator to every part of the equation. And then I'll be able to cancel things out and solve the equation that you have left. It might be a simple linear equation with an x to the first power, or it could be a quadratic equation where we have an x to the second power that we have to solve. Okay? So let's take a look here now at the examples that we have. And we'll start with example number 1. We've got 3a minus 6 over a equals 5 over 2 minus a minus 1 over 2a. Okay? First thing we want to do here is figure out what's our common denominator. The parts of our denominator are a, 2, and 2a. Okay, those are our parts. So my common denominator here is just going to be 2 times a. That's my common denominator. So I'm going to take the whole fraction times the quantity 2a over 1. Okay? And I'm going to distribute this times everything that we have. Okay? So when I do that, this is what I get. I'm going to write this all out. So I've got, on the top, I've got 2a times the quantity 3a minus 6 all over a equals 2a times 5 all over 2 minus 2a times a minus 1 all over 2a. Then notice the bottoms didn't change yet because I'm just multiplying them by 1. I take every top times 2a. Okay. Now, once I've done that now, I'm going to try and cancel things that are the same on the top and the bottom. So I'm going to cancel this a with this a. And I'm left with now, you'll notice I don't have a fraction here anymore. I'm left with 2 times the quantity 3a minus 6. Over here, I'm going to cancel the 2's. And I'm left with just an a times 5 or a 5a. On the third fraction, I'm going to cancel out the 2a's. And I've got a minus the quantity a minus 1. And now you'll notice I have now eliminated all fractions from our problem. So now I'm going to distribute the negative here and distribute the 2. So I've got 6a minus 12 equals 5a minus a and plus 1. Okay. Now I'm going to combine my like terms. So 6a minus 12 is 4a plus 1. Subtract 4a. Add 12. And now my a value, if I divide by 2, is going to be 13 over 2. Or, if I make it a decimal, it would be 6.5. Now, the one thing that you're probably going to want to do before you solve this is do your domain. And you'll notice on all your domains with a monomial, just like before, in this case, a cannot be 0. Anytime we have a monomial or a one-term item, it's always going to be 0 there. Okay? So that's the first example. Now let's take a look over here at the second example. We've got 3 over k minus or the quantity k plus 1 over k squared, and that's going to be equal to k plus 5 over k squared. Okay? Again, got to figure out the common denominator. My parts are k and k squared, so my common denominator is going to be k squared. So I'm going to multiply everything by k squared over 1. Here, here, and here. It's got to go to all three parts. So I've got 3k squared. Okay, I've got 3k squared all over k minus a k squared times the quantity k plus 1 all over k squared. And that's going to equal k squared times the quantity k plus 5 all over k squared. Okay. Now again, before I go any further, I'm going to go ahead and knock out my domain here. And again, my domain, k, cannot be 0. Okay. So now I'm going to go ahead and cancel things that are the same. I've got one of these k's on top, cancels with this k on the bottom. I'm left with a 3k. This k squared cancels out with that k squared. I'm left with a k plus 1. And this k squared cancels out with this k squared, and I'm left with a k plus 5. Now, the reason I left the parentheses on this middle one is because I've got a minus sign here, which means I have to distribute it. So 3k minus 1 equals k plus 5. Combine my like terms, 2k minus 1 equals k plus 5. If I subtract k minus 1 equals 5. And if I add 1, k is going to equal 6. Okay? All right, let's take a look at the third example now. Okay, third example here. We've got 1 over x minus x over 9 equals 0 this time. So, got to figure out common denominator. Parts in the bottom are x, 9, and if I were to put 0 as a fraction, it'd be over 1. So, my common denominator is 9x. So I'm going to multiply everything here by 9x over 1. And I got to distribute it to everything. So on the top, on the very first fraction, I'm going to get 9x over x. 9x times 1 is 9x. 1 times x is x. Minus a 9x times x over 9. And that's going to equal 9x times 0 is still just 0. Okay? So now I'm going to do my domain. Again, my domain, because it's a monomial, x can't be 0. So these guys cancel out. I'm left with a 9. Minus. These 9s cancel out. X times x is x squared. And it's going to equal 0. Okay? So now I want to solve this. All right? So when I want to solve this, I want to get x squared to be positive. So I'm going to add x squared. 9 equals x squared. And now I'm going to solve this. I'm going to take the square root of both sides because I don't have a middle term. So in this case, remember, when we take the square root, x is going to equal both positive and negative 3. So in this case, I had a quadratic equation, and I had 2 possible answers there. Okay? All right. This concludes part 1 of solving rational equations with just monomial denominators. Don't forget to do your WSQ for this part 1 of section 8.6.